All right, so we were discussing about this type conversion functions, right, in Python. So I was saying, like, if you wanted to add these two variables, one of the way you can convert this into a string by directly writing, x equals to in a string format 1, 2, 3, and then you can add this operation and it won't throw any error. But there is another way. You can say str of x, and this str function will convert everything whatever the value of x is in the string format, and then you have y equal to Sachin, and then you can simply add these two variables, right? So there are other conversion functions also, like string. We have float. So whatever you write inside the float, any number or anything, not only number, even if you write anything, it will be converted in a string, sorry, float format. Then you have complex. So all these are functions. Okay, so when you write complex, so it will convert any number into a complex number, a plus ib format. Then you will have a dictionary. This is also a function. Then you have a tuple. So it will convert into a tuple. We haven't seen what is dictionary and tuple. We will come to it, don't worry. Then we have something called as ORD. And what this will do, whatever you write inside it, it will convert it into a Unicode of that particular thing, whatever the data is available inside this. Now, what is the meaning of Unicode? Let's understand this. So if I write something like this, let's say we have x equal to in a string format a, and when I say y equals to ORD function of x, and when I try to print the value of y, what I will get the value as 97. You know why? Because small a, this is a small a, and there is a whole bunch of thing called as ASCII characters. So when you just simply go and Google ASCII table, or let's say ASCII value of A to Z, and let me just open this first link. So see, capital A is 65. Here is the table we have, right? And if you just search the value of small a, here I can't see. Let me just directly Google it. Sky value of small a. See, it is 97, right? In lowercase. In uppercase, it is 65. In lowercase, it is 97. Now, what is this ASCII value and why it is used? So your keyboard, whatever you are using, right? That is the only way using which you can send the input to your computer. There is nowadays another ways also, like you can voice command also. But you know what happened? That voice command also gets converted in a text format only. If you are sending voice, that voice is going to convert it into a text format. So eventually what you are doing, either if you are typing or you are speaking to your devices, nowadays you speak to your devices like Alexa or Gemini or Chat GPT, but internally they all are being converted into a text only. And then that text is gonna be converted into a binary language, because computer only understand the binary language. So there are a bunch of abstraction level. First, let's say your voice. or your maybe text, these things will go inside the computer, and everything is going to be converted into a text format, and then that text format is going to be converted directly or indirectly. There can be a multiple steps between this, but finally the goal is everything is going to be converted into a binary language. Okay, because computer only understand this binary language. And there is a reason why computer only understand the binary language, because inside your processor, how the processor is made up of, they are made up of transistors. Okay, transistors. And this is pure electronics topic. I have learned in my engineering, but no concern with here. But yes, those are transistors, and that's why your computers only understand this binary language. Now, here is the thing, like when you say A, so your keyboard, on the keyboard, when you type A, that A is going to be converted into a number 97, because that's the Unicode assigned to that particular, and this is a standard ASCII value. So even if I type A in my keyboard, or someone else type their A in their keyboard, so all of them are going to be converted into a 97. That's the code assigned to that particular keyboard value A. And then this 97 is going to convert it into its corresponding binary. And then finally a computer understand that someone has typed A on the keyboard. And this process happens very fast, because you have a very fast processor to understand this everything. So that's why when you say ORD of A, small a, you will get the output as 97. Python interpreter decodes this. Any doubt till here in the type conversion? Okay. All right, then let's see some coding with respect to this. I will share my another screen to that. Mhm. Can you see my other screen, guys? The Anaconda
Not
screen?
yet.
No.
No.
Let me share it once again. Yeah, now?
Yes, I do.
All right. So I have launched my Anaconda, and I want everyone to install in their system this Anaconda Navigator. It's a simple install. Go to Google and just whatever system you are using, Windows, Mac, depending upon that, you just have to ask to Google Anaconda install, and then your system, Windows or Mac, and from there you have to install this. And within this Anaconda Navigator, I'm going to launch the Jupyter Notebook. All right, so on the desktop folder, I have already created this Python folder, and we have the day one of all the code, whatever we have done. I'm going to create another file and name it as a day 2 of Python. So this is the Python notebook. We call it as a IPYNB file, interactive Python notebook file, in which we can run our Python programs. There is another way also, VS Code. I have shown to Kishore. So if you guys watch the recording, you will get how the VS Code also works. I can name it as day 2 of Python. All right. Now let's start from there. The example which we have seen for the memory management. Let's say if I say a equals to 4, and then let's run this, and then I will print the ID of a. So when I print ID of a, it will give me the memory location where this a is stored. So let's run this. I have to close this bracket properly because for print I haven't closed this. That's why it is giving me the syntax error, incomplete input. Let's close this and run it once again. Now this is the memory location. Okay, just see carefully, look this memory location. Now what I'm gonna do, I will say a equals to, let's say, Sachin, and run this. And now when I print the ID of a, tell me what will happen, guys. Is it going to refer the same memory location or a different memory location?
Different memory location.
Yes. See, this memory location and this memory location is totally different. But what if I say, let's say x equals to a now, and when I say print ID of x, now what will happen?
It will take the memory of string.
Memory of A.
Yes, so the same memory location it is taking, right? Cool. So that was the concept I tried to explain. And now let's see the type conversion operations. By the way, in this notebook, you can not only write the code, you can also use something called as markdowns. So let's say I'm on this particular cell, and if I convert it into a markdown, so you can write your topics. This is a notebook often used by data analysts and data scientists to do their experimentation and try to understand line by line in the code what happens. So usually whatever experimentation is done by the data scientists, they write it over here and then present to someone else. So that's why it offers a lot of features to us. So I will use the markdown also, and after 2# I will, let's say if I say type conversion, and when you run this, see it is coming like this. So in type conversion we have seen, like, let's say you have x equal to same, I will take 1 2 3 y equal to Sachin, and then when you try to add x plus y, it will throw a error, unsupported operand type s for plus integer and string. That means you can't add integer and string type of data types. So the one way is you can write x equal to 1 2 3 in a string, and then y equal to, you already have y, and then you can say x plus 1. So now it will run. Okay, we are getting the output. But let's say if I do x equal to again 1 2 3, and then if I do x equal to int of x, so I'm converting this, sorry, not int, string. I'm converting this integer into a string, and then you can say y equal to, you already have anything, any string value, and then you can try to add this x plus y. Still no error, right? We have also seen the Unicode one. So let's see how the Unicode works. For example, if I take x equal to a, and when I convert ORD of x, and when you try to print it, by the way, you don't have to write the print statement again and again in the notebook. If you are just, printing the one, if you are just dealing the one variable in a one cell, it will automatically print the value. So if I run this, it is automatically printing 97. But let's say if you have multiple variable in one cell, then you have to use the print statement. Okay? So it is giving us 97. You can also check for, ORD of, let's say you can directly give the value. Let's say if I give capital Y, and let's try to print this, it is 89. Any doubts so far? Anyone?
No, sir.
Okay. So now, since this is clear, we can jump to the next topic and understand some number systems. Let me share my this whiteboard again. Can you see my other screen?
Yes, yes, yes.
All right. So handling number systems in Python. Okay, so what are these number systems actually? So those who have, coming from the science background, they must understand what is this number systems. But those who are not, there are multiple number systems, we deal with. As a human, we deal with something called as decimal number system. Decimal number system in our day-to-day life. And what is this decimal number system? It consists the value between 0 to 9, right? So no matter what the number is, how big number is, it will only consist only these digits, okay, from 0 to 9. Correct? And that's why, since it has on total 10 values, we call it as a decimal. So decimal means 10, decimal number system. We have another number systems also. One of them is a binary number system. Okay, so what is binary number system? We can only have the value 1 or 0. That's why we call it as a binary number system, and machines or computers only understand this one. Then we have something called as octal decimal number system. Octal decimal number system or octal number system. Octal means 8. So we will only have the values between 0 to 7. Okay, this is one of the number system introduced in maybe 100 years ago. That's a older system we have. Then we have something called as hexadecimal number system. Hexadecimal number system. So hexa means 16. Okay, so it will include our decimal number system from 0 to 9, and it will have some extra characters, and those extra characters are A, B, C, D, E, and F. So 0 to 9 is 10, then 11, 12, 13, 14, 15, 16. So using this, you can create as many numbers as you want. Okay. So these are the 4 popular number systems we have, and we don't have to go, very much depth of this, how this, you can, convert any like a number system to any another number system. Like if you have a number, let's say, 1000 in your decimal number system. So how the 1000 will look like in a hexadecimal number system, how the 1000 will look like in an octal number system, or in a binary number system also, you can do that. But there is a whole mathematics behind it, how it works. We don't have to go inside the whole mathematics. But I will show you a programmatic way using which you can, convert these number systems. So let's say if I take one example to just explain you. Let's say you have a number 6 in decimal number system. Okay, in decimal number system. And I want to convert this 6 into a, let's say, binary number system. So how I can convert it? Does anyone know? What is the equivalent of this 6 looks like in binary? Any idea, anyone?
No idea.
No idea. Okay, no worries. So, there is a mathematics, but I am not going to teach you that mathematics because as a Python programmer, we never need that mathematics. But I will give you the trick how you can convert it. Okay, that trick represent that mathematics only. So you will write something like this: 8421, and then multiple of this, like 16, 32, 64, and you can keep writing the double number.
Okay.
And since we have 6, so now add these numbers. By adding which numbers, it is making a 6. So when you add 4 and 2, it will make 6, right? So
Yeah.
This 4 and 2, you write 1 and 1 over here below these numbers, and remaining numbers are 0. So this will become 0, 8 will also become 0, and all the remaining numbers are 0. Now in computer, there is something called as precision. Okay, remember this term, precision. This is very important term. Precision tells us that how you are storing the your data. So 6 is what? It's a data, right? It's a number, it's a data. How you are storing your data inside the memory, with what precision. So if I use only 4, and by the way, these are called as bits. These are called as bits. So this is the smallest unit. Okay, and we call this as a 1 bit, 1 bit, 1 bit, 1 bit. So together we are calling it as a bits. So let's say if I'm going to use only 4-bit precision, 4-bit precision. So I'm going to represent my numbers with the 4 bits. So 6 can be easily represented with the 4 bits, right? So the equivalent of 6 in the binary will look like this: 0, 1, 1, 0. In the 4-bit precision, this is an important term, in a 4-bit precision. Let's say if I tell you don't use 4-bit, instead of use 5-bit. So within a 5-bit also, the 6 is going to look like same, right? 1 and 1, here 0, here 0, but within the 16 also you will write 0. So 1 0 will be added. If you want to use 6-bit, 1 more 0 will be added, but representation of 6 for this 2-digit will remain 1, remaining digits will be 0. But let's say I will take another example. If I take, let's say I want to represent let's say a number called as 38. Okay, so do you think by adding these numbers, can you represent 38 with the 4-bit precision only? So 8 4 12, 12 2, 14, and 115, right? So you can't represent 38. So you need extra bits, right? So let's write this, how those extra bits can be achieved. So you have this 32. Now 32, and we need 38. So for 32, you will write 1.
And
And then you
4.
need to add 6, right? So 4 and 2, right? So here
Yeah.
it will be 1. Here it will be 1. Then remaining will be
0.
0. So at least how much bit precision you want? 1, 2,
6.
3, 4, 5, 6. At least, right? Maximum you can go up to any bit. But at least to represent 38, you need 6-bit precision, right? 6-bit precision. In computer, we never use 6-bit, 7-bit, something like that. We use 4-bit, then 8-bit, then 32-bit. So power of 2, 2 to the power of n. We use this kind of system. Okay. And
Okay.
when you use 8-bit, we called 8-bit as a 1 byte. Okay. When you use 8-bit, we call it as a 1 byte. And when you use 8 byte, right? 8 byte, we call this as a I don't remember what we call byte. And then after byte, we will have yeah, like from here only your megabyte, kilobyte, all these things are coming. So let's say when you use 1024 bytes, 1024 bytes,
Megabyte.
it will become 1 kilobyte, not megabyte, 1
Yeah.
kilobyte.
Correct. Correct.
So that's why we call it as a 1 kilobyte. Then when you use 1024 kilobytes, it will become 1 megabyte. Similarly, 1 gigabyte when you use 1024 megabytes, and so on and so forth. That's how your RAM also decided, in your phones and in your computers, because they are using 2 to the power of n, the same thing. I hope this is clear for binary thing.
Yes, Sachin.
Okay, great. Now, there are same formulas for octal and hexadecimal. We won't go inside that because there is no much need of that. But let's write some programs so that you guys can understand how you can convert some number system from one to another. So I will share my another Zoom screen. Handling number systems. So, let's say if you want to represent any number in the binary format, so you can use this kind of thing. Like, let's say I will use some, this is called as comments. Okay, I will use a single line comment, binary number. So let's say I have x equal to and I want to represent a number, let's say 101, which is a binary number. Can anybody give me a decimal number of this 101 using that trick 8421? Just convert it in a decimal number system, how it will look like.
2, 4, 8.
It's a 5, right?
10.
No, it's a 5.
We start with 2, right? 2, 4, 8, right?
8421. Na? So 8 is missing. So 8 is
Oh,
going
1
to
is
be 0.
okay. Okay.
Yeah.
Okay.
So since it's only 101, 3-bit is there. Now, when you say x equal to 101, and when you run it, and when you check the data type of it, so using type, you can check the data type of x. And when you run it is calling it as an integer. It is not treating it as a binary. In order to convert this in a binary, what you have to do, you have to say x equals to 0 and then b, and then if you write 101, and when you now check the data type of x, it should be converted into a binary. What happened? It is still saying as this thing only. Let's say if I take another value, another variable y, and type of y. This is weird. 0b101. Okay, is it 0 or O? Let me just check. This has been changed. Zero B should be working fine, but I don't understand why it is treating it as an integer only. Okay, let's try this 0x equal to 0x, and then let's say 3f, and then type of x. This is weird. Okay, anyways, I need to check this, why this is coming like this. Maybe, I'm using Python 3.12, and this must have changed according to the previous version. So that's, I have to check why this is coming like this. But anyways, if I do something like this, no, let me just treat it in this way. Let's say 0b101, and instead of y, let's say if I print the value of y over here. Yeah, now it is coming. So yeah, actually, when you check the type, it will show you the integer type only. But when you print it, then it will be converted into a binary language. So that was the catch actually. In the previous version of Python, when you check the type, it has converted like into the the binary only. But with the newer version of Python, so actually Python is keep on changing. We are using the 3.12 version of the Python to learn. Before that, we have version 2s, and in version 2 also like 2.1, 2.2, and so on and so forth. So there can be a little bit, syntax changes they release, every 2 months, 3 months. Python is a very active community, and all the releases you can check on their website. Like if you say Python, yeah, that's it. This is their official website. When you go to their releases, see, as the latest, they have Python 3.13.12. We are using Python 3.12.9. Okay. The reason why we are using Python 3.12.9, because 3.12.9 is the stable version, and 3.13 is still not the stable version. So that's why you can see, minor changes. They won't make any major changes. Remember this. They only make some minor changes. So that's why the earlier, like when you say type, it was able to convert it directly over there into the float. But now the thing is, like when you are saying 0b, so 0b explains that it is going to be a binary number. When you try to print this, it will give you the binary output. Okay. Sorry, the converted decimal output. So that's how it works. Now let's say if I, this is a hexadecimal number, okay? 0x3f, it's a hexadecimal number. When you print the x, it will, give you the corresponding decimal number. So 63 is represented as 0x3f. This x can be small also, okay? When you run it, it will give you the same output. So 0x prefix means it's a hexadecimal, 0b prefix means it's a binary number.
Binary.
And let's say if you want to do for octal, so you will say 0 and then O. 0 O, let's say C equals to, and this O can be small and capital both. And let's say in octal I have written 10, and I want to see in decimal how 10 will look like. So print C. So 10 in octal is equivalent to 8 in decimal number system. All right.
Yeah.
You can use something like this also. Let's say we will say you can convert, I mean, change the number system also in this way. Like let's say if you have written print, let's say this is the hexadecimal number system in X we have, and I want to convert it into a binary. So you will say bin, this is a direct function we have, binary of X. And I'm just printing that value. By the way, this print is not required. Even if you remove the print, it will print it because we are in the Jupyter notebook. And if you're dealing with one variable in a one cell, it will print the value. So when you run it, see in the binary, this 3f, okay, this 0x is just a prefix. So 3f is represented as 111111 like this. Okay. By the way, you can understand this. 3x in a decimal is 63, right? To represent 63, we have these many bits required. And you know the trick of how to convert
1, 2, 4,
binary.
8.
Yes.
16. Okay.
Right. Similarly, you can convert, similar to bin, you can use oct. Let's say octal number you want to convert. Let's say this is the number 101. This is a binary number, right? I want to convert it into a octal number system. So I'll say octal of y and run it. I'm getting, so 0O is a prefix. You don't have to do that, but this is the 5. So 5 in a octal and 5 in a decimal are same. You know why it is same? Because in octal 0 to 7 and in decimal 0 to 7, they are gonna same. That's why till 0 to 7 in octal and till 0 to 7 in decimal are also going to be the same. After 7 in decimal, we will have 8, 9, but in octal, we will have different values. We won't have any